Hello, young men. GCF, greatest common factor. So we're going to use our understanding of finding factors by using the factor pair strategy in order to find the greatest common factor. And I like to use a Venn diagram just to keep my work organized. So let's say we're looking at 18 and 24. And we want to find the GCF of 18 and 24. All we have to do is find the factor pairs for each. And then we're going to put the ones they have in common in the middle. And then the largest number in the middle is the greatest common factor. Simple as pie, right, guys? So, you always start with 1 and the number itself. 1 times 18. 2 times 9. 3 times 6. We know 4 doesn't work. 5 doesn't work. And if you put 6, you'll be repeating. Then we find our factors of 24 by using factor pairs. You always start 1 in the number. 24. 2 times 12. 3 times 8. 4 times 6. 5 does not go in, or 5 is not a factor, because if you did 24 divided by 5, you will wind up with a remainder or decimal. And if we go on to 6, we'll start to repeat because we'll have 6 times 4. So now we know that we have all of our factors. This part is very simple. All you have to do is compare the numbers on each side. Now, the problem that a lot of scholars have is that they do not make sure that they go through each number to ensure that all of the common factors are in the middle. So we're going to go through each one on each side. Do they have 1 in common? Yes. I circle it. And the reason I circle is to make sure that I covered it. To make sure that I looked to, basically organization, neatness, and, revision. Do we have 2 on both sides? Yes. Circle both the 2's. Put it in the middle. Do we have 3 on both sides? Yes. Do we have 6 on both sides? Yes. Do we have 9 on both sides? No. Do we have 18 on both sides? No. So now we know that we found all of the factors that they have in common. So the common factors between 18 and 24, or for 18 and 24, are 1, 2, 3, and 6. But our goal right now is to find the greatest common factor. So let's think about it. If we're looking for the greatest common factor, obviously we're looking for the factor that they have in common that is the largest number. So our GCF, or greatest common factor, would be 6, because 6 is the largest out of all of the factors that they share in common. Let's look at another example. 8 and 12. We create our Venn diagram. And we use our factor pairs to help us find the greatest common factor, along with the Venn diagram for organization. So we always start with 1 and the number. 2 times 4. We know that 3 is not a factor, and we already have 4. It's starting to repeat, so we know we have all of our factors. Let's do it for 12. 1 times 12. 2 times 6. 3 times 4. And then it's starting to repeat, because then we would have 4 times 3. We have all of our factors for both numbers. Now we compare them. That's the point of the Venn diagram too, because you know that what they do not have in common you would have here, and what they have in common you'll have in the middle. That's another reason why you're circling it, because it's kind of like you're getting rid of it because you're placing it in the middle. So they have 1 in common. 1 is a common factor for all numbers. Do they have 2 in common? Yes. And if you notice, I'm going in order. Everything that I do with factors, multiples, and mainly anything you do in math, you want to keep the order, the consecutive order, just to make sure that you've gone through every number or every step with fidelity or properly. Do they have 4 in common? Yes. Circle of 4s. Do they have 8 in common? No. So now we know that we have all of the common factors. You could say the CFs, common factors, are 1, 2, and 4. But we're looking for the GCF, the greatest common factor, which would be 4, because 4 is the largest number out of the common factors.